Hello everyone, I am Praveen Kumar Mohan, a data analytics student at National College of Ireland. In this video, I am going to present you about my research project proposal, which is audio speech emotion recognition using ensemble boosting machine learning models. Let me first start with a brief introduction about the domain, the speech emotion recognition system that I have chosen for this project. Now we humans are in a world where we rely much on machines for everything we do more than the fellow persons. I would say this is mainly because of the advancement of artificial intelligence in all areas. And this led to the human computer interaction, which had increased leaps and bounds. And humans started interacting with the machines in natural language, like how a human and human interaction would be. To make this interaction more natural, friendly, effective, the speech emotion recognition system are used in the machines to better understand the human emotion which they exhibit. Understanding of human emotion is not an easy task, as the natural form of human speech is not just the word but the emotions, which can vary with just a small change in the modulation of the same word in the speech. So, this challenging problem motivated me to build an effective speech emotion recognition system using machine learning algorithms. Also, such a model can be extremely useful in the robots or machines, which are used to assist the blind or visually impaired people, as they can interact with the machines only through their voice. My proposed research question is, how can an automatic audio speech emotion recognition modeling help the machines better understand the emotion or feelings of a visually impaired speaker? The emotion that my proposed model would be identifying from the audio speeches are neutral, calm, happy, sad, angry, fearful, disgust, and surprised. Since speech emotion recognition is a hot research area, many researchers have already explored a lot in the past, and they had built their own models based on SVM, extreme learning method, backpropagation neural network, and decision trees. After an intensive analysis of the literature, I found only very few researches were done using ensemble machine learning models. So I have decided to explore this area using ensemble boosting methods like AdaBoost, extreme gradient boost, and gradient boost. Out of the three popularly used methodologies across industries, I have opted to use the methodology named Cross Industry Standard Process for Data Mining, which can also be shortly called as CRISP-DM. The six phases of this CRISP-DM methodology that would guide me through this project are understanding the speech emotion recognition importance, where the business need of emotion classification is studied, followed by the understanding of my input data. In this kind of research, mostly people will use audio or visual input files, and for this particular project, I am going to use audio files. The third phase is where we do the data cleaning, data pre-processing, feature extraction, and feature selection on all those audio input files. After that, we'll be building our proposed machine learning models and evaluate them based on their performance in the fourth and fifth phases of the methodology, respectively. The final phase is to deploy the best model for an effective use. My proposed design has three layers, where the source code of the model will be developed using the program R in the RStudio, and it will be in the data persistent layer, and all our business logics will be implemented in the application layer, and the final visuals or the report would be presented to the target audience in the presentation layer using tools like Excel, Tableau, Microsoft Power BI, etc. And on the right is my activity diagram, which clearly shows the steps that are going to be involved in my proposed implementation of the project. After building the models, I'm going to use three different performance metrics to evaluate my proposed model's performances. They are confusion matrix, precision, and recall. The reason why I haven't used accuracy as a evaluation metric here is it's not always good at saying how the actual positive cases if I had correctly classified. Finally, I would like to conclude saying that by end of this project, an effective speech emotion recognition system will be built, and most of our audio speech files will be correctly classified based on the right emotions. I would also like to highlight here that a successful implementation of this project would definitely be a game changer in the AI powered robots those are used to assist visually impaired people. And it is a time which I should never miss, as I would like to thank my lecturer Dr. Catherine Molva for her outstanding support and guidance which driven me throughout this project proposal process. Thank you.